Hello, everyone. My name is Martin, and I'm a software developer working in a small team together with a close friend of mine, Marcus, who will be having his talk right after this one, and he'll be going into the details that we use on a day-by-day basis when working on our projects. So he'll be talking about mutation testing, and I'll be hoping to set the stage with respect to the core axioms we have identified and that we use to back our process. And we always are on the lookout to find new rules that enable us to minimize the time that we have to think about simple things, actually, because it's boring to think about the simple things, and it just takes time that could be spent way better by thinking about the actual hard problems that you have to solve on a day-by-day basis. And our thinking was that if we lay down rules that we can all agree upon, so to say, that we can form a shared set of values that will just do away with a lot of questions that we typically encounter when we are programming, especially in a team. And our team is completely remote, so everyone is working actually almost from some other continent. And the only means of communication we have is written, because we decided that talking or video conferencing or stand-ups or something like that is actually just hurting our productivity. And so it has a lot of value if everyone can agree that if we're facing a decision, we will actually reach at the same answer, because then you don't have to discuss about it, right? And there'll always be things that you'll have to discuss, but it's better if these are the interesting ones, right? So yeah, with that, I want to go to the objectives that we all probably have as software developers, and those are to minimize bugs first and foremost, probably because clients hate bugs. And not only clients hate bugs, we as programmers hate bugs too, because when they occur, it means that we have to interrupt our usual flow, right? And we just have to go to something that might have happened months or years ago, maybe. So yeah, obviously, I mean, we want to minimize these. And just as a heads up for the whole talk, I hope that most of the things I'll be saying will be like, yeah, of course. I mean, so when I say something, I actually want to say some sort of universal truth. No, that's probably the wrong word, but that's the reason why we use the term axioms, actually, because axioms are sort of that. They are statements of universal truth that you can then use to build upon, right? So the next important thing that we also always want to do is minimize downtime, right? So I should add that the setting, the project we're working on is a web application. So, I mean, that probably goes without saying. So it just needs to be live all the time, because as soon as it isn't, clients are angry. I've already said the part that we want to minimize the thinking about simple things, right? But there is a really important aspect too, and that is that we've agreed upon that we actually want to learn as a team every day when we do work, right? So we're keen to find a process that actually allows us to learn while we work on it. We don't just want to solve problems for clients. I mean, we obviously do, but we want to learn while doing so, because part of being a programmer is some form of curiosity to improve your craft, right? And I think once you've stopped improving, then it gets boring in a way, right? So that's a key aspect also. So we are constantly questioning our process and see if maybe we've done something wrong in the past, or maybe it wasn't so much wrong, but it can still be improved. So we're always on the lookout to learn something new. Another aspect is that we want to share responsibility within our team. So we don't want to run in a situation where someone is to blame for a bug, right? Because eventually you'll be the guy who writes a commit and it's your code and you put it live, and as we know, bugs happen. I mean, the best process cannot prevent all bugs, but if it happens, it's better if you don't feel too bad about it. And one way to reach that is to ensure that your process has in its very core the aspect that you are not responsible alone, but you're acting as a team, and the team carries the weight with you, right? It's not like you should go home and start, I don't know, crying because you lost I don't know how many dollars for your client, right? So you want to share that responsibility with your team members. And the most obvious objective is, of course, that we want to satisfy our clients, because that makes them happy and that leaves us in our job, right? With that said, we'll start with the axioms we've identified. And these, as I said, are the sentences that are supposed to be, well, of course. So what is an axiom? I've already said it before. It's basically a sentence that forms a truth that you don't need to question, because when you hear it, you're like, of course, that's true. And once you have these sort of sentences or statements, you can then, and it's universally accepted that they are true, then you can build on top of them. Like, you can apply logical reasoning, not in the strictest mathematical sense, but still you can say, if this is true, then this is very likely to be true also. So you can use the core axioms to build assumptions that will, after discussing with team and refining them, are almost or even exactly, you can be sure that they are true as well. So with that said, we're right now, I'm listing a few definitions of terms that will be used throughout that talk, and axiom is the most important one. So we all probably agree on what an axiom is. The next thing, I've already mentioned it, is assumptions. Those are the next level, second level sentences that we derive from our axioms. And that's basically what we did and what we do every day. We reiterate on the axioms, on the decisions, on the assumptions that we made, and we constantly try to find new assumptions that we all can agree upon that they are true. And this talk will basically mention a few of those assumptions, and because these can then form the basis for some kind of constraints that you can put or enforce in your development process. One of the most prominent things in this sense is the concept of transformation. And it's not, I mean, I'm using this as a definition for transformation, and it's obviously just in this very narrow context, but transformation basically, when we talk about transformations, we talk about any update to system artifacts, like every kind of code change, every kind of infrastructure change we do, every kind of data change also, which, as we all know, happens through code, because no one, I don't know, edits production data live in some client, right? So it's all code. And when we talk about transformations, we are talking basically about commits. So every commit you do is a transformation to the source code, and it turns out that there are actually only a very small set of transformations that you typically do when you write commits. And this talk will go on to introduce those kinds of transformations and the fact that they seem to us to have an implicit ordering when you do them, which again relieves you from thinking about it, right? If you have just a few possible transformations, then you know that the next commit you'll be doing will be one of these transformations, right? And then you're like, okay, I can do this, then I can do that, then I can do that. Another term that probably doesn't really need a definition is regression, but I figured I'd add it nevertheless because we use it not in the most common sense, like where you say a regression is a bug. Well, of course, a bug is some misbehavior in your production application, but a regression is slightly more abstract because we consider a regression to be everything that puts the system into a worse state. It needn't necessarily be a bug that clients call you afterwards and are like, the system isn't working. No, it can be way more than that already. Like when you commit something into your repository that violates your rules, that regresses the code base, the quality of your code base, then that's a regression already, and you want to minimize those because if you can make sure that every commit is an improvement, then you don't have regressions. Obviously, regressions will land in the project, but the goal is always to minimize them. Which not directly leads me to this very important aspect, but I've been mentioning before that we're doing transformations to our code. We commit to our code repository, and I've already said that we have a very small set of transformations, and the key aspect for every single one of those transformations is that it should be atomic, which basically means you cannot make it smaller. If you change a running system, you want to do those changes in the most minimal way possible, because not only is it easier to review for your teammates, but also the impact it has on the running application is very small. That is not to say that we want to do small impacts. Obviously, we want to make a lot of progress, but if you change a complex system in tiny, 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 tiny steps, and always make sure that you're making progress while doing so, that seems to us to be a smart way of doing it. And it has a few consequences, like it can be applied very easily. It can be reverted very easily by extension. And as we know, bugs will land, so if we can revert quickly and we know that the state will be reverting to is valid, then it's not so much of a problem if something goes wrong. Obviously it is, but the revert will be easier, right? There is another concept that we're doing, and we're having a lots of checks for the code we commit, and we have the distinction that everything we do to see if a proposed commit matches our intentions, we call it check. But there's actually two different kinds of checks. You can have automated checks, and we call them tests, right? We use continuous integration, obviously, and we're referring to the checks that can be automated as tests, whereas we refer to reviews, whereas we refer to manual checks as reviews, right? So they are equally important, both the key differentiator is that an automated check allows you to minimize the time you spend checking on it, which again leads to, or is based on the premise that you actually want to minimize the time thinking about simple things, so there's no point in constantly repeating, making a human do checks that a machine can do. It's not possible for the human to be replaced by a machine, but you want to minimize the attention the human has to pay. And on reviews, what we typically do is we'll flag violations of any of the rules that we've established. So we call that a flag, and it's basically the result of a manual check. It will always appear as some form of comment in GitHub reviews, because that's what we use. But yeah, a flag is basically a failed check that was identified by a human. Okay, two very quick ones, axioms. I think we can all agree that clients hate bugs. We can all agree that clients love progress. So that should be very obvious. The most important axiom that we have identified, and actually we think that almost everything can be boiled down to this, is that redundancy, redundant code, redundant semantics, they don't provide value, right? If it's redundant, it doesn't add value. So why would you want to add something to your code base that doesn't add value, right? It makes no sense. This will be key, and everything is boiled down to that, and Marcus will have his talk after mine, where he is introducing his tool Mutant, which is a tool for mutation testing. And this is key to our process, as it helps us to remove redundant semantics. Because what Mutant does is it tells you, hey, you can do something simpler, or hey, you don't need this at all. So it's an automated way to check Ruby code for redundant semantics, for redundancy, which we want to remove. The next axiom, and that's obviously kind of related to redundancy provides no value, is that inconsistency provides no value. We've been discussing if it's even worth mentioning because it can be reduced to the first one, but my thinking is that it's a bit more obvious if we mention inconsistency specifically, because it's mostly about style, right? So semantics are observable on the one hand, and inconsistencies are the things where your colleagues wants to write it this way, you want to write it that way. Find a shared way to do it. So you want to look at your code, and you don't want to spot any difference if you or your coworker wrote it, ideally. So that's what we're referring to by inconsistency. It's basically things like white space. Do you align your code with 2 spaces, with 4 spaces, whatever, style issues like this. One very important other axiom is that human attention just varies over time, right? Not everyone is in a perfect mood, in a perfect mental, you don't always are equally smart, right? There are days where you're smarter, there are hours during a day where you're smarter, and that will vary. And you want to catch the times when you're not so smart, right? So you want to have automated checks in place a lot of the time for when you're not so smart, right? So that's a key thing. You have to accept that first and foremost, you're probably not as smart as you think, but even when you're especially smart, there will come a time when you're actually not so smart, a few minutes later. One obvious truth is also that automation reduces the need for human attention, right? If you have something automated, you don't have to think about it. Another obvious truth is that required semantics change over time, right? What your clients tell you have to do this, Next day they tell you you have to do this. So the required semantics change over time. That's why we commit to our repositories in the first place, right? An interesting one is that we all know that the tools we use aren't perfect, but we can imagine what a perfect tool would do, actually, right? That's not so hard. It's hard oftentimes to write the tool and make it closer to perfect, but it's easy to say, the tool should have spotted this. It doesn't, but I spotted it as a human, so I will check for this as well. So if you have an agreement in your team that on reviews, on manual reviews performed by humans, you actually act as if you were a perfect tool, right? So if you can agree that the tool should identify this, you should flag that on review because it is a problem you have agreed upon. An assumption that we're basing on all these axioms is that a well-defined process can actually help a team to increase its performance. And that's basically what we're getting at. So we want to define a process that will help us to eliminate most of the various inconsistencies, questions, things we need to think about. And another very obvious conclusion is that automated checks are to preferred over reviews then. I'm sorry if this is repeating more or less, but I want to stress the fact that these seem to us to be very obvious truths. Another thing that kind of relates to the fact that you're probably not as smart as you think is that it's actually not possible to understand all the required semantics that your clients think of in a very different way than you do. Usually you have business clients and they are on a much higher abstraction level than you are. You are a programmer, they communicate their intent to you, but you will probably never really know 100% what they actually want. So it's impossible to always know what it should work exactly like. And I'm not talking about a sorting algorithm, which is supposed to sort. Exactly. Yes, exactly. The interesting thing, or that's a personal observation, clients tend to think that they know precisely what they want. We programmers do as well, but I'm here to remind that actually no, we don't either. But it's a good point. Yeah. Kind of related to this is that the mental model you formed about your project will probably be wrong. It's not so much that it's wrong at any point in time. I mean, if it's really wrong, then you have a problem. But the key thing is that it will change. So you'll identify a flaw in your mental model, and it will happen every day, right? Why do we refactor? If we have a perfect mental model, then there is no need to refactor. We just write the perfect code. No, we can't. So our mental model is wrong most of the time, and it will change. Which kind of not directly leads, but makes us think that if we identify constraints that we think constrain the model, we should ingrain that in the system as deep as possible. We shouldn't add it somewhere on top, and to use one of the probably very few Ruby mentions in this talk, it's nice to have validations on an active record model, but you want to move those checks down into the database. You actually want to make check constraints and constraint triggers and whatnot. So you have to push those down. You want to make sure at the lowest level in the system that bad stuff cannot enter. Coming from the other direction is that while you should push down your constraints as far as possible, you should reject invalid input as soon as possible, right? As soon as someone is sending you data that you should process, you should immediately check it, and if it has problems, just reject it. You return some appropriate HTTP error status and be done with it. It's coercion of data sometimes is the right thing to do, but more often than not, I'm thinking that if the data is wrong, reject it. Another assumption that relates to reviews is that you should never self-censor, right? When you are reviewing code from one of your colleagues and you think that it has a problem and you spot it, don't be shy and hold it back. Don't think that your colleague may think that you are not smart. Just be open about it. Say that you think there is a problem. The best thing that can happen, or the worst thing, depending on the way you look at it, I tend to think of the best thing is that you learn something new, right? It's not like your colleagues will be, well, you're dumb, that's obvious. No, a good team says, more or less, thanks for the comment, but here's the way I look at it. Okay, so that was kind of the introductory part about the core axioms that we use, and now we come to the transformations that I've been mentioning before. So basically the way we allow ourselves to change the code base. And you'll see it's five of them. That's not a lot. And that's nice because those are the only options you have. And if you combine them with the atomic principle, so that every transformation has to be atomic, and to reiterate, it has to be the smallest possible transformation. You cannot break it up further. Combined with that, those are actually the ways you can change your system, right? You can remove something, you can remove code, right? You can fix code, you can refactor code, and you can change code, which basically is changing the semantics, right? Or you can add new code, or to be even more precise, you can add new public API. Because if you're adding just a private method, I'm not sure if that qualifies as a true addition to the source code. Because as long as you don't add new public API that will be used somewhere else, it's probably a refactoring otherwise, right? A key thing that you might have noticed in that table is that we have assigned priorities for these, right? And those priorities are a guideline, first and foremost, probably. Those are not hard rules. But to maybe jump a bit ahead is that these verbs that are called transformations here, your commit messages maybe should start with those, ours do. And if a commit message does not start with one of these verbs, then it will be rejected by CI. Continuous integration will say, no, your commit message is wrong. Because what kind of transformation are you doing that is not in this list? And there will be a slight amendment to that, but we'll come to that in a bit. So when I'm talking about priority, again, it's a guideline, and there'll be tiebreakers, right? So if you're not sure if you should put this first or you should put that first, then you want to be able to fall back to some rules that help you decide where to really put them. And the most important rule of these is kind of obviously functional dependencies. So when on this list say we want to remove first, and sorry for not mentioning it, the priority order is actually within a pull request, right? So these transformations, they actually apply on the commit level, but they also apply on a pull request level. So when you do a commit, or when you do a pull request, make it this way, and you want to remove something and you want to add something, you typically want to remove first. You always want to remove first, because everyone likes removing code on the one hand, but you can also look at it from a way, if you are able to remove something, then it puts the system in a better state, because it's less code. Less code to maintain, less code to think about, less possibility for bugs, right? The next thing you typically want to apply is fixes, right? Because you want to get fixes merged into your project as soon as possible. The only thing that might be even nicer to do before that is to remove code, because it removes the potential for you to have to do a fix in the first place, right? So this is all based on the assumption that you want your changes to the code base to land as fast as possible on master, and we're doing continuous deployment. So every pull request, when you hit the merge button, it gets deployed, 0 downtime, and you want to have it live as fast as possible, right? So these two are actually very important. Like we rarely find reasons that these should not come before, or that anything else should come before them, apart from the fact that we sometimes need to respect functional dependencies between our changes, right? So if we have to refactor something to then be able to remove something, that's what we mean by a functional dependency. So in this case, you might end up having a pull request where you actually have refactoring commits before you can then do the final removal of the code, right? Also, it has the aspect of risk associated to it, because if you have nice test coverage, and you should strive to have that, a remove is actually not really risky. Because if you have tests for all the call sets, and obviously you need to do some acceptance testing before merging as well, then it's fairly safe to remove. Because if your tests aren't even able to catch that some important code has been removed, then you have other problems and should probably be working on your test coverage, right? Fixes equally, I mean, if we find an agreed, or if we can agree about what's wrong at the moment, and you have a team that can review and assert that the commit is actually fixing something, then it's probably not too risky. This will always depend, but I'd say that the tendency is that removes and fixes are fairly riskless, depending on the quality of your tests and your review process. The next thing, which is a kind of interesting transformation, is a refactoring, because it's actually the only type of transformation that kind of performs a look ahead, right? The others, you can almost always say, or you can measure objectively if they form an improvement on the one hand, or if they at least don't introduce a regression. You don't need to look further in the pull request. You don't need to look at the next commit or the next commits to identify if these are really an improvement. No, the intention is that every commit must be an improvement. I've established that before. Every commit should not leave the system in a worse state. No, it should leave the system in a better state. Refactorings are different, because you have to explain to your coworkers why you think that this change at this specific time actually leaves your system in a better state, because you will in the future use the new code to perform the next transformations that you're using. And it's more optimal to perform it on the refactored code than it is to do it in some state where the code is not yet optimal. So you oftentimes want to do refactorings as fast as possible, right? Or as soon as possible, actually. So if you want to have some addition, you want to add something, and you find that the system isn't in an optimal state to actually perform the addition, you want to refactor it first, because then you can operate on more optimal state. You don't want to add something to some state that you know that is suboptimal. Why not make the state optimal first? Also, that has the nice consequence that if a pull request is going on for a very long time, then you can say, okay, I have ordered my commits on a few dimensions, and I've moved things that we agree that should be merged first. I moved them to the top of the pull request, so I can just extract another pull request from that, right? And try to get the uncontroversial transformations merged early. And then just leave the remaining commits in the pull request, because these might need further discussion, right? But you can get the agreed upon, the less riskier stuff, you can get it out of the way, which in turn reduces the diff size your reviewers have to look at, which again reduces the mental overhead for the reviewer, which again reduces the time the review takes, which again makes clients happy, because you can progress faster. Right? So refactorings, you typically want to move them highest up in the chain. So this priority should actually be read in a way that everything wants to move up. There is another kind of transformation, a change, and that's basically something where you say, okay, the system has had a specific behavior initially, and it's not that this behavior is wrong. Okay, it's not that this behavior is wrong, but the behavior has to change. So that's a very common thing. I think usually all our commits, we think of them as changes, but some of them are actually, or a change is something more specific. An addition, like I said before, is an addition to the public API. You're adding new code. You're not changing any semantics, you introduce new semantics. And then we have a few synonyms, and I'll just go quickly over these, because these are the last 4 words that we allow in our commit messages, and they are basically just shortcuts for the various kinds of changes. So we move something. If we move some code from here to there, we want that to happen early. And it's basically just changing the location. If we rename something, it's a sort of a move where we just give a different name. And again, it's better to have the optimal name in the system first and do the rest later. Upgrade and downgrade are very obvious. It's when you deal with your dependencies. And these should always actually, like if you're working on a pull request, you always want these to be the only commit in your pull request, right? If you upgrade some system, you want to merge the upgrade so that you can just revert the upgrade and not mix it with any of your other code. Okay, and I'll really go quickly over these constraints. Those are the ones that we actually put into place in our system. Again, redundant semantics must be eliminated. Marcus will do his talk on mutant and how it helps greatly with that goal. Automated test coverage must not regress. It must be at a certain level. If you add a commit to it, you should not allow regression coverage to regress. If you have known bugs, give priority to fix them, because that makes clients happy. As I said, every commit must be an improvement. Every commit must be atomic. It should be the smallest possible change that you can do. Every commit must pass all automated tests and review, so all checks need to pass. And every commit must be deployable. Like if you make a commit, it must be in a state that you can deploy. If you take one commit out of a pull request, you want to deploy it, you want the system to have no problem. Every single commit must pass all checks, and then you are able to deploy it. Master is deployed. Right, every deploy must be approved by a reviewer. I think we've established that for now. Everything a perfect tool would flag must be flagged. Just in case code should be rejected, because why? Why do you want just in case code? It's redundant at this point, right? And we said redundancy doesn't provide value. I've already said that the commits can be ordered along the priorities of the transformations, and this should be checked. It's a check that can only be done by a human most of the time. And the obvious things that that I've mentioned before, that the limits we place on our commit messages. So the conclusions: redundancy provides no value. That's really the key thing. If you have something that you're not sure if it provides value, don't do it. Why would you? Humans are, attention level is unstable. Respect that. Adjust your process around that. And with that, I think I'm done. Thank you.
You said that when you do the refactoring, the tests should not change, but then in the transformations synonyms, you presented the renaming and moving the code from one location to another, and this is the refactoring in my understanding. However, it usually means that tests will change. So what do you would like to comment on that? Is it still refactoring, or is it something else, or?
Typically, these are the move and rename commits. We can, I guess, go back to these really quickly, right? You can, if you're developing atomic commits and you say that a move is actually, when you move something, you can't really break that up further. When you are refactoring, oftentimes you can extract a move from that refactoring. So a move probably forms some subcategory of a refactoring, but it qualifies as a separate improvement by itself. So again, it's about making things smaller. You can refactor code and move stuff around with it, or you can say, hey, I move it to a better location. That's the improvement, and that's worth it without the rest of the refactoring. Because if I move it, I'm already in a better state, and the change I do is smaller. The transformation I do is smaller. Right?
Thanks for the presentation. I was wondering how the process of introducing this approach looked like, because I guess it wasn't like overnight that you sit.
No. So, and that leaves me with a very important point, actually. Deeply sorry I haven't done that further. All this work or all those insights arrived after years of discussions, initially starting with my colleague Marcus and Dan Kapp, which is our team leader, and I think we both owe him great and many thanks. And it's the insisting on trying to refine the process to reach the goals in a more consistent way that that made these simple truthy statements happen. So no, that's not that definitely didn't happen overnight. That's been a refinement of years, and this talk was probably just able to touch the surface of everything. But you need to be very rigid. You need to have you need to be a person that wants to be that rigid. The nice thing is, if you can agree on it, then it's actually very simple to establish. The hard thing might sometimes be that you have clients that accept that level of strictness that allow you to have the room to do those decisions as a programming team, while not saying no, you have to deliver. Even though this whole process is meant to be able to deliver faster and actually leads to faster delivery.
Thank you.
Thank you very much. Could you please switch back to the table with priorities?
Mm-hmm.
Oh yeah, so I was thinking, how is actually fix and change different from removal and addition? Because when I'm thinking about it, it seems to me that when you're fixing or changing code, you're essentially removing or adding some features, some code.
Yes. So a remove is what you always have to keep in mind is that we are talking about the smallest possible change, right? Atomic changes. So a remove would typically, like if you see a diff, it's red lines, right? You remove those lines. You see no green lines, or maybe you see at the call side some adjustments, but it's really removing things. A fix, and I think that's the distinction you were looking for, is basically a violation of any kind of the rules we have established. So those are things like if there is redundant white space somewhere in your code, you don't want to interleave that white space fix with other fixes. You just extract that, and that's one example, right? But the key discriminator for fixes is actually that you had suboptimal state and you are fixing it to be better. It's not necessarily a bug fix where there is bad behavior in production, but like I said before, it's you spotted a regression that made it into the code base and you're fixing it that way. But I think that your question boils down to the concept of atomic commits, where you are really trying to make each change as small and indivisible as possible. So it's very easy to have an add commit that contains a few removals, that contains a fix along the way, that changes semantics along the way, and 90% of the diff lines are green. So you could say, well, I'm adding code, right? But if you really apply atomic transformations, then these fall into smaller categories. And a typical add commit could more often than not probably be broken up into a sequence of these smaller transformations that then can be ordered the way I...
Thank you.
Okay, I think we are really out of time, so you have to catch Martin in the after party.
I'm happy to.
So thank you. I think we'll start 5 minutes later anyway.